Hey guys, I'm just gonna do a quick how to make these coils, the big beefy ones. So what I do is get the drill here all hooked up. I've made my bobbin here. Here's the met glass rod. It's right into drill. And I'm just gonna turn it so that it's rotating towards me. A lot faster than that though, but just showing the direction it's turning towards me. And I'm gonna get, I think on this one, I'm either gonna put 19 or 21 wraps on this bobbin. It's quite a bit bigger. This will be the biggest coil I've ever made. This is 24 gauge. It's I don't know. It could be anywhere from 17 to 21 is what I'm gonna put on here. I'm undecided yet. We'll see how big it is once I get going here towards the end. I'll know. And there's something else. Oh yeah, okay. Once I'm done with this all the way around, once I have all my wraps, it's gonna end up over here. And that's important to do always an odd number when you're doing this. You don't want this end to come back over here. You don't want to have an even number on these coils. It has to be like 3 or 5, something where it ends up on the opposite side, not on this side. And then when I start the 19 gauge, I will have this started on this same side, but I'm going to turn the drill around like this and change the direction of its rotating so it's still wrapping up towards me. The direction of the windings doesn't matter. The only thing that matters is the polarity when you're hooking them up. But the reason I do it like that with this is to make it easier to hook it up the right way when you're wiring it up after. Because if you do it the way I'm doing it, these wires will go to a certain spot, and these wires will go to a certain spot, and I already know where they go without having to do any troubleshooting to figure that out. So, I'll be back with an update here. Okay, I've got 19 wraps. So I start over here. 1, 2, 3, has to be an odd number, so you end up on this side. And it's important to have the imbalance on here. You don't want it to end up back over here. So now what I'm going to do is just pull this out. So now wrap that so that the drill it's rotating towards me. So now it's kind of heavy, but I think it'll stay. Don't want to drop that. But now I'll change the direction of the drill so it goes this way towards me like that. And now I'm going to fill that spool up with the number 19 wire. And once I'm done, I'll do all the ohm readings. So I know I have 19 wraps on here right now. So when I'm done, I'll measure it. I'm not going to count the wraps of the number 19, but I'll give dimensions of this spool. And actually I'll measure the coil here too right now. If I could put this down here, I'll get my... I think I have one in here. Just give me a quick second, I'll get it out. Okay, we got this here. Measure this coil best I can with one hand in the camera anyway. Come on. 27.84 millimeters. So when I'm done, I'll measure the final wraps of the number 19. This is 24 gauge. And before I hook it up, I'll get the ohms per coil. Hey guys, I'm done wrapping it up here. Stupid charge controller. It's charge controller for my wind turbine. The wind turbine brake is almost always on, so it doesn't read anything. It's just always in resting unless I need it. But here's the 55. And it's about 57.24 millimeters on the final thickness of it. I've got it all coated with resin too. It's all ready to be hooked up. Let's do some ohm readings here. This is the 24 gauge wire. $13.5. You can see that. 24 gauge. I think the last one I did was 11. This one's 5 ohms. Not sure what the last one was when I measured the 19. So the 19 is 5, and the 24 was 13.6. And that's it. It's all done. It's ready to go. Clean it up a little bit. And it's about as good as I'll get it because I used all the wire in that spool. I was going to make it a little bit thicker, but I wasn't going to splice together anymore. Number 19. I just used what was left on that spool and called her good. Should be good anyway. Hey guys, so I've got this all hooked up here. Just give it a quick burst of power, and it seems pretty interesting here. So let's try to hold this and get these in frame. I can get it to turn on. There we go. Stupid inverter fan. I just took it off till that fan turns off. I can't go over 60 volts because that's only a 63 volt cap. And I can see the power's climbing quite fast with 26 volts here. And yeah, there's the current's going. Trying to hold it on. I'll just clamp it on there. Yeah, this coil looks pretty impressive, what it's doing. Yeah, looks pretty good. First test results look pretty impressive with it. I'm just going to drain it here a little bit and do that again. Okay, I've drained it to 23 volts or so. I don't know what it's going to do because I've never had to cap this low with this coil yet. So see what might. It's pulling 630 milliamps. So I'll just leave it up, hooked up. It's not too much. And here the coil, filling up its capacitance. Watch the current. There you go. See more copper, it took longer to fill it, higher voltage to fill the coil up. But it's probably a lot more efficient too though. The ratio is a little bit different. I think my last coil, the one that's in here, this one here, it's right there. There's a lot of copper on that one too. But I think the ratio was can't remember. It was either 9 ohms with the 24 gauge or 11. On the 19 gauge, I think it was 4. Somewhere around 4 ohms. Can't remember for sure, but I think that's where it was. I'd have to take it apart and measure it. Not really take it apart, just undo one end of each one. I already don't even remember what this one was, but it'll be in the coil construction video is where you'll find those numbers. I think the 24 gauge was 11.6, if I remember right. Or 13.6 ohms. And I'm pretty sure this one, 19, was 5 ohms. So that ratio is a little bit off, like different. So, but quite a bit more copper. Let's drain this again. That transistor should be cooler now. Yeah, it's not too bad. Drain that cap again. Try it again. Bring it down. It's a 25 watt bulb. Hook this up again. 20 volts. For that inverter fan to shut off. Just leave it hooked up. It's only pulling 700 milliamps. You hear it. All that current is going into filling the coil up with its capacitance. Yeah, that's pretty interesting anyway. To me anyway. I like seeing it work. Thanks for watching, guys. Okay, guys, so I got this hooked up. New circuit here. Bigger diodes, same type as the previous. They're just a bigger 14007 diode. So I got it hooked up. Caps are in series, 63 volts each. They just go up here, got them up there so they don't hang off the side and try to pull everything off the bench. I discharged the caps, they're kind of recovering on their own there, but let's see here. So at 26 volts here, it gets somewhere around 63 volts output. Just see how it reacts here. I'm just gonna tap it until I get the voltage high enough in the cap. You can hear the coil popping. There, it's starting to turn on. I'll just leave it do its thing now. Keep an eye on the current and the voltage. There you go. Just like that, it's at its peak voltage at this input voltage. If I put more volts in, I can get much more out of this. But I'm looking for efficiency. It doesn't have to be a high voltage, I'm just looking for the magic numbers, which I've already seen on the previous coil. I'll have some info coming up with that. It's been running for a while now, and it's not going down in energy, I'll tell you that. And the bigger diodes, I think, are probably going to be a little more efficient. It always seems that way. Paralleling them up helps too. You can just do this here and take it out of resonance. When you hear it making noise, that's not any good. Right around the 50 volt area. So I'm just tapping it here. You can hear it pretty good. Current disappears, charging rate doesn't change. If anything, it goes a little faster until it hits where it stops. Doesn't really stop, it's just the meter changes its numbers there after. It looks like it's climbing faster at these lower numbers, but it just, because the decimal point moves over. It does slow down though, obviously. I'm not sure what the top voltage is, I haven't checked it out. But short video, just wanted to share that. Thanks for watching.